Okay, math students, here we are again with our chapter 8.5, absolute value equations and inequalities. Today we're just going to talk about the absolute value basics, so getting us started with solving some of these equations and inequalities that have an absolute value symbol in them. Again, remember when you're watching these videos, you can pause at any time and rewatch these videos if you want. Also, ask your teacher if you've got some questions or concerns. We're going to start out with vocabulary today. Again, pause, copy down the vocab, and then I'll go through and explain this so you can listen to the explanation. The first word is equation. It's a math statement that contains an equal sign. An inequality, the in means not equal. In this case, it really could be less than, greater than, less than or equal to, or greater than or equal to. So any math sentence containing any of these symbols is an inequality. Absolute value is the distance away from zero on a number line. Absolute value is always a positive result. Because distance is always positive, you're measuring a distance. So absolute value, the answer is always a positive. We're going to talk about some equations that you can have negative variable values, but overall the absolute value has to be a positive. Opposites, they're also known as additive inverses. These are numbers that have the same absolute value, but they have different signs. For instance, like 8 and negative 8. Those would have the same absolute value. They're both 8 units away from 0 on the number line, but one is positive and one's negative, so they'll have different signs. To graph, here we're talking about graphing equations and inequalities on a number line. To graph means to locate and place dots on the solutions for a given function on a number line. So if you're graphing equation solutions, you're going to use just dots. If you're graphing inequalities, you're going to use dots, either open or closed, depending upon if it's less than or maybe less than or equal to with that line under it. And then you're also going to include those arrows to show all of the solutions for that inequality. Set notation, or sometimes referred to as the solution set, that's just that. It's the set using these brackets to show a group where you put the solution or where you write your answers. We use these when we have more than one answer for a variable. So maybe n equals 2 numbers. So we would put both of those numbers inside of this bracket and we'd separate those by commas. Moving on to the notes. Again, these are the absolute value basics. There's 2 pages of notes, so pause the video, copy these down, and then listen to the explanation. In our first example, we're looking at the absolute value of negative 23. We said absolute value is the distance away from 0 on a number line. So the absolute value of negative 23 is positive 23. Because it's a distance, distance can never be negative. In the next example, absolute value of positive 23. Well, that's still 23 units away. So notice how these 2 equations, these 2 values, even though one was positive and one was negative, using these opposites, they both have the same absolute value. So it's okay to have 2 different equations inside and you still get the same absolute value result. We would call this negative 23 and positive 23 opposites. That's part of our vocabulary. In the next example, we have the absolute value of b equals 7. So if we look back at the first one, we can look at the opposite of 7 and 7 as our 2 solutions. So we have negative 7 and 7 are the 2 solutions. So our solution set would be those bracket symbols again with the 7 and -7 shown. B equals both of those. In the next example, write an equation to show what solution is graphed. So if we look at the solution that's graphed, it looks like we have a -3 and a +3. There's no variable given here, so we're just going to use the variable n. And in this case, since we have two answers, one's positive and one's negative, those are the opposites of each other, but they have the same absolute value. So our equation becomes the absolute value of n equals 3. So in this case, n could equal +3 or n could equal -3. There's two solutions that are graphed, so two solutions for n. When you work with absolute value, there's always two cases. In the first case, everything inside the absolute value symbols has a positive value. Or, just like in the last example, we had +3 was one of the solutions. Or case number 2, everything inside the absolute value has a negative value. In the case before, n equaled -3. So case number 1 and case number 2 have to be considered every time you have an absolute value problem. So in the next one, we're looking for what could y equal? So there's going to be two answers for this absolute value problem. In case number 1, we're going to set up y plus 2 equal to 3. That's our positive inside the absolute value. For case number 2, we're going to set up y plus 2 equals -3. Now, when we solve these, we're going to solve them just like a regular one-step equation. So we go ahead and do a -2 to both sides. In this first case, we get y equals +1. Okay? And in case number 2, we're going to get the same steps, but we're going to end up with a different answer. So we do that -2 to both sides. This time, because we started with a -3, -3 plus -2 equals -5. So our solution set looks like y equals our little bracket 1 and y can equal -5. So we get two answers dealing with our absolute value. Looking at our next set of examples, we're looking at the general form of absolute value equations. So the last one we did was looking at when the numbers were equally spaced apart, when 0 was our center. We could see how far they were away from 0 on the number line. In this set of examples now, we're looking at numbers that aren't always centered at the 0. They're not always equal distance from 0 on the number line. So our general equation is the absolute value of x minus m. In this case, x is going to be our variable for our problems. M, we're going to take the m out and put the middle number on our graph in place of the m. So it's actually going to be x minus some number is going to be in there. And it's going to equal d. In this, d is going to be the plus or minus distance away from the middle. So you're going to start at the middle and then you're going to go forward however many spaces, our d distance, and backwards the same amount of distance. So you're kind of representing that absolute value being a positive and a negative and looking at that equal distance apart. Okay? So how does this look when you're looking at an equation? Well, if you look down here at this next example, you can see that 0 isn't in the middle of our equation. Right here, is our middle. So this one isn't centered on the 0. So this is where we're going to write one of our equations using that general form. So we're going to set them up all the same way. We're going to start with an absolute value, and we're always going to start with x minus something, okay? So we're going to look at, we know the answers are 1, -1, and +3. So when we put those on the number line, we're going to find where's the middle of these two numbers. So it's kind of like finding the average of these two numbers. So here we have our middle. So that number that's in the middle, in this case it happens to be 1, that's what goes into our equation. So our equation is going to look like the absolute value of x minus 1, okay? And now we need to figure out what it equals, okay? We need to find out what goes over on the other side. So what goes on the other side is our distance. We're looking for what is the distance away from the middle. In this case, we're looking, start at the middle, and you want to count how far is it out to those solution points, okay? So since our middle was at 1, how far is it from 1 to get over here to 3? So from 1 to 3 is only a difference of 2, okay? So this distance up here was 2, and then if we went backwards, if we went to the left, it'd be like a -2. Since absolute value can never be a negative, we just write it as a regular 2. So there's our equation. Absolute value of x minus 1 equals 2. That's it. You don't have to solve it because it's already been solved for you and it's already been graphed for you. So all we're doing on these is writing the equation. So it's kind of working backwards. You start with the answer, you work your way backwards to find out what the problem was. Again, watch these videos again, repeat, ask your teacher any questions if you have any. Thanks. Have a great day.